Attention is given to flow patterns within the LANIAKEA supercluster. 4 regions will be isolated. There is the region of the historic local supercluster. There is the great attractor core of LANIAKEA. There is the Antlia strand, a part of the Centaurus Puppus PP filament connecting LANIAKEA and Perseus Pisces. And there is the Pavo Indus filament extending to the Norma cluster. The Milky Way lies at the origin of the orientation arrows, red SGX, green SGY, blue SGZ, of 20 megaparsec length. There is a high density of orbits near the Milky Way because most nearby galaxies have accurately known distances and velocities. In the local supercluster region, essentially all galaxies on or above the supergalactic equator, positive SGZ, are moving down toward negative SGZ. In this region, galaxies flow toward positive SGY and negative SGX, the direction toward the core of LANIAKEA. Orbits in the region of the local supercluster were studied in detail by Shaya et al. 2017. The scene shifts to reveal the complex structure that runs from Virgo through Centaurus Hydra to the 4 clusters region. The coherent flow from the local supercluster to Centaurus becomes confused in a global view, with flow basins around the Centaurus and 4 clusters. An overwhelming downward flow from above the supergalactic equator, positive SGZ, is seen across the whole region. Flows upward from negative SGZ are also seen, although patterns are more chaotic. Below the supergalactic equator, in the vicinity of the origin, the flow is predominantly toward negative SGX and Centaurus. A coherent flow rises from low SGZ through Hydra and Antlia along a substantial structure reaching Centaurus. Above the supergalactic equatorial plane, that is aligned with the red orientation arrow, orbits are systematically downward, swooping toward Centaurus. The Pavo Indus filament that lies south of the Milky Way plane, negative SGY, is another major component of LANIAKEA. Prominently, flows are toward the spine of the filament and then along the filament toward negative SGZ and positive SGY through the Norma cluster. Here, detail is lost behind the Milky Way, but the flow emerges to reach the Centaurus four-cluster core of LANIAKEA. The presentation shifts to projections of orbits onto deeper surfaces of density from the quasi-linear model. This view is from positive SGZ. A slice is considered bounded by minus 20 less than SGX less than plus 20 megaparsec. The view from positive SGX contains most of the historic local supercluster. The knot to the right of center contains the Virgo cluster and is end-on to the band of structure running toward Centaurus. The Fornix and Eridanus complex are lower left of center. A piece of the Great Wall in the vicinity of the Coma cluster is at the extreme right, beyond the Hercules void. This slice has the bounds 0 less than SGY less than 40 megaparsec. The bound SGY equals 0 is roughly coincident with the plane of the Milky Way. The view is from negative SGY. Most structure in this slice lies horizontally on the supergalactic equator. The prominent exception at the left is the Antlia strand portion of the Centaurus Puppus PP filament. An outline of the boundary of LANIAKEA passes mostly through voids. This slice has bounds minus 80, less than SGX, less than minus 20 megaparsec, and the view is from positive SGX. The scene contains the densest parts of LANIAKEA, but clips the local supercluster that lies to the foreground. The scene is restricted to the Pavo-Indus filament. the scene shifts to the dense core of LANIAKEA. This slice, minus 20 less than SGZ less than plus 20 megaparsec, is viewed from positive SGZ. This band about the supergalactic equator captures most major features of LANIAKEA. The Perseus-Pisces filament at lower right and Great Wall at the top pass almost vertically through the supergalactic equatorial zone. They are separated from LANIAKEA by voids and flow patterns of separation. Part 3 gives attention to the Perseus-Pisces filament.